Remember, in our case of having two VLANs, VLAN 10 and VLAN 20, they cannot communicate with each other. So PCA, unable to send traffic to server D, as well as PCB, will unable to send traffic to server C. And maybe you're thinking, how can we do intra-VLAN communications? Well, before we talk about intra-VLAN communications, let's talk about default gateway first. And what I'm gonna do is I'm gonna replicate our topology, this topology to this space. Okay, let's replicate this. I'm gonna have a switch, and take note, these are layer 2 switches. They don't have routing capability. It doesn't have routing table, and it has limited features. So this is the switch, and let me highlight, this is layer 2 Ethernet switch only. There you go. And what I'm gonna do is I'm gonna add PCA here. What else? PCB, server C, server D. There. I'm gonna add those interfaces E1, E2, E3, E4. Okay, and I will also gonna assign VLAN 10. So this is VLAN 10. I'm gonna add the network 192.168.10.0. This is .1. This is .2. I'm gonna specify /24. Okay. What else? I will also assign VLAN 20 to PCB and server D. Now, let's configure default gateway. The thing is, we're only processing traffic using layer 2. Okay, and this is based on frames, and it cannot route from one network to another. Now, if you attempt to send traffic from PCA to PCB, it will say, hey, the destination is a different destination. The destination of this VLAN is 192.168.20.0/24. You see, on the perspective of PCA, it will try to send traffic to a different network. And this is the part where it should rely to a layer 3 device. Okay, this is where it needs a default gateway. So what we're gonna do is we're gonna configure default gateway to PCA and server C. Okay, default gateway with a value of 192.168.10.254. I will also configure a default gateway PCB and server D. Default gateway with a value of 192.168.20.254. There. Okay. Now, we still don't know what this default gateway is. This is what we're gonna do. We will add a layer 3 device. And when we say layer 3 device, it can be a router, it can be a firewall, it can be an application load balancer. It doesn't matter as long as it's a layer 3 device and it can process multiple network. Okay, now what we're also gonna do is we're going to specify an uplink. Yeah, we're gonna add an uplink. Let's say this is E8 and another uplink for E9. Okay, for E9, it is red, so this is VLAN 20. Now for the router, I'm gonna add E1 interface and E2 interface. Each interface has a corresponding IP address. Now for the E1 interface of the router, I'm gonna assign an IP address of 192.168.10.254. Yeah, so this interface has this IP address value. For the E2 interface of the router, I'm gonna assign 192.168.20.254. And as you can see, maybe you're wondering, is this the default gateway for the VLAN 10? Absolutely. Is this the default gateway for VLAN 20? Absolutely. So the default gateway is our layer 3 device. In this case, it's the router. Now, here's what's gonna happen. Let me just remove this. Here's what's gonna happen. If PCA needs to send traffic to PCB, what it will do is it would know that, hey, I am sending traffic to a different network. Therefore, I need to consult with my default gateway. Now, the default gateway is within the same broadcast domain. I can actually do something like this. Okay, I can do that. They're in the same VLAN, VLAN 10, and but I will put back to the original. It will send the traffic to E1, the default gateway, 192.168.10.254. And the router will do its magic. It will check the routing table and it will decide if it can forward the traffic to the destination. So what is a routing table? Remember, in switch, we process our traffic based on CAM table, the MAC address table. In router, we process the traffic based on the routing table. The routing table looks like this. Routing table, and I'm gonna create a box there with a value of, okay, so the value of the routing table in this case is not too complicated, it's pretty basic. We have this value. Okay, why? Because it is a directly connected interface and it knows that this interface, by the way, this interface is not a layer 2 interface, it's a routed interface, also known as layer 3 interface, where we can directly assign an IP address, same interface that we have in our PCs, okay? 192.168.10.0/24, and this is learned via interface E1. We also have another interface, which is E2, 192.168.20.0/24. So in its routing table, it already learned two networks because these are directly connected networks. Here's what's gonna happen. The router, as it received the traffic from PCA, or it can be server C, it doesn't really matter. It will check the destination. In this case, the destination is server B with an IP address of 192.168.20.2. The routing table will check, do I have a network to the destination, 192.168.20.0? And as you can see in its routing table, yes, it does have a network in its routing table destined to 192.168.20.0. And what it will do is, it will check which interface should I forward the traffic to reach to its destination. It's E2. So it will forward to E2, which is also configured as VLAN 10 to E9 interface of switch 1. It will forward it to switch 1, and switch 1 will forward it to the destination.